G'day. Today we're going to be looking at the neurobiology of behaviour at the systems level. Last time we looked at it at the cellular level. Now we're going to look at what happens between cells. And the contents of this topic are the dynamics of interacting neurons and neural systems. So first, the dynamics of interacting neurons. And in this segment, we're going to be looking at neural networks, memory storage, and creativity. Now, the brain consists of networks of neurons. Neurons on their own can't do a lot, but if you put them together in networks, they do a hell of a lot. And the neural network among themselves with neurons of other networks. Power in our brain, it consists of networks talking to networks and overlapping networks. Okay, so we move on to memory storage. There's not enough neurons for each to contain a single piece of information. So the brain has to come up with a fancy way of storing information with a minimum amount of storage space. And this information is contained in the firing of neuronal networks in specific patterns. So it's not so much like in a computer hard drive where it's a bit like a parking space and memories or information is put into each parking space and then retrieved later. It's a question of information being taken from one network and used by another network. And so that bit of information can have multiple purposes in the brain. And memory retrieval is a result of tapping into many networks and integrating all of these inputs in a construct a memory. So mild damage to networks does not destroy memories, rather it makes it harder to retrieve them. So you're not destroying the memory, you're just making it harder to remember, okay? Now, creativity, individual differences in overlapping networks cause people to know different information. And basically, the more overlapping between networks, the more creative you're likely to be. In other words, the easier it is for your neural networks to talk to each other, to connect with each other, then the more creative you're going to be. Neural systems, that's the next thing on the list. And in this segment, we're going to be looking at the definition of a system, types of systems, the limbic system, and the autonomic system. And the definition of a neural system is a neural network that networks that work together to enable a particular function of the organism. So it's not just a single network, it's a bunch of networks connecting with each other and sharing information. And we have sensory systems that include vision and hearing. And we have motor systems that enable us to move around and talk and move our faces. Now, different types of systems. We have central components, which include the central nervous system, made up of the brain and the spinal cord, and peripheral components, which include the peripheral nervous system, such as the sensory neurons on the body's surface. So you've got the central nervous system and the peripheral nervous system. Now, the motor sensory system connects the brain and spinal cord to skeletal muscles, and the autonomic nervous system connects the brain and spinal cord to heart, lungs, and other internal organs. And as the name implies, autonomic means it works by itself. So you don't have to consciously make your heart work or make your lungs work or other internal organs work. They work all by themselves thanks to the autonomic nervous system. Now, the limbic system, that regulates emotions and is situated on top of the hindbrain below the cortex. So it's inside the brain and at the back, and is found only in mammals. That's why if you have a pet chook like I do, you're going to get, you might get a lot of satisfaction from watching the chook be absolutely real. Like there's no complications in a chook. However, you're not going to get any emotion from them. They're not going to come up and hug you or ask for a hug. They won't even like you nursing them usually. So I've got species of chooks that don't like being held. So there's no point trying to hug a chook because they don't have a limbic system like mammals do. Dogs, you can do all sorts of things with dogs, pat them. I believe they actually don't like being hugged as such with your arms around them, but they do like being patted and tickled, but not actually hugged. So it's the mammals that have the limbic system, and the major areas of the limbic system are the amygdala, the hippocampus, the septum, the hypothalamus, and the frontal cortex. Now, the amygdala and septum have roles in aggression. The hippocampus has roles in learning, memory, and stress. The frontal cortex inhibits behavioural or inhibits inappropriate behaviour. So the frontal cortex is like the conscious part of your brain that you do your executive work in. So in other words, you decide with this frontal part of your brain which bits of emotional behaviour you're going to allow or not allow, if you could possibly can overcome your emotions. And to put it in a metaphor, the frontal cortex is a bit like a stage, a very small stage in a very large theatre, and it's a lot of floodlighting on there, but it can only hold a few actors at a time. You can't get very many actors on there, and the rest of your brain, which is the 90% of your brain, that is not accessible to consciousness. So the part that's not accessible to consciousness, the non-conscious part of your brain, will choose which bits of its contents it's going to put on the stage. And there's usually a bun fight for which one is getting on the stage, because it'll depend upon the strength of the emotions associated with that particular issue that you're dealing with. Usually the strongest emotion will win, and the weaker emotions don't. The hypothalamus is associated with sexual behavior, food, hunger, and the circadian rhythm, okay, or food hunger, I should say, and the circadian rhythm, which is the daily process we go through from waking, working, resting, sleeping, and then waking, working, resting, sleeping, and so on. Okay. Now, looking at the autonomic nervous system, it regulates the involuntary functions throughout the body and has two components. There's the sympathetic nervous system and the parasympathetic nervous system. For someone of my age, it's sometimes hard to get my tongue around some of these words. The sympathetic nervous system releases adrenaline and is used in emergencies. The parasympathetic nervous system releases acetylcholine, which triggers a calm state. So you've got the two systems. One, the sympathetic one, is used to get you all hyped up and going, like the fight or flight response. And the parasympathetic system is used to calm you down. Although the heart is able to beat on its own, the sympathetic nervous system causes the heart to beat faster and blood pressure to increase. So when you get that shot of adrenaline, your blood pressure goes up, your heart beats faster. And the parasympathetic nervous system does the opposite. It slows down the heart and hopefully lowers blood pressure. Now, thought and memory serve as stimulants to the autonomic nervous system. Stressful thoughts and memories cause the sympathetic nervous system to release adrenaline, causing the fight or flight response, and peaceful thoughts and memories are caused by the parasympathetic nervous system releasing acetylcholine and producing a relaxed state. And also we have plasticity in the autonomic nervous system. In other words, it's not set in concrete, it can change. And there are three ways it can change. It can change by habituation, by sensitization, and by biofeedback. Now, habituation is the process whereby the same stimulus will not have the same effect on the autonomic nervous system. So in other words, with time, if you get used to a particular stimulus, it won't produce the same overreaching effect that it did in the first place. In other words, you get used to it. And sensitization is where you weren't a particular sort of threat or stimulus wasn't a threat in the first place, like when you first experienced it. And over time, you become sensitized to this particular stimulus, and it does become a trigger for your sympathetic, your autonomic nervous system. And the third one is biofeedback, which is a conscious tool for controlling the unconscious workings of the autonomic nervous system. In other words, they sit you in front of a screen which shows some parameters, and they ask you to think about calm thoughts or threatening thoughts, and you can see your data, your bio data going up and down, left and right. See what happens, and by thinking the right thoughts, feeling the right feelings, you can actually control this bio data, as you can see it on the screen. And you can calm yourself down when you're over anxious if you think the right thoughts or feel the right feelings. Okay. And of course, as usual, there are individual differences in autonomic nervous system function. So some of us will be, have higher blood pressure than others. Some people will suffer from depression and anxiety disorders, and others won't. So it's as if, well, as we saw before with Darwinian evolution, we have mutations that are passed on to us from our parents, and we also create our own mutations by our lifestyle and things that happen to us in our life. Events can cause mutations. And these mutations can have an effect on the autonomic nervous system, I should say, raising your blood pressure, for example, increasing your anxiety, making you depressed, and all sorts of other things that you would rather not have. Okay, so that's all for today. It was rather short and sharp. And very soon I'll have another one for you, and then we'll see where we go from there. Okay. Bye for now.